Hi learners. In this session, we shall learn about various rules of differentiation. Then what about logarithmic differentiation, etc.
Exponential and logarithmic functions. The exponential function with a positive base b greater than 1 is the function f given by f of x equals b power x. Here b is what is called the base and x is the exponent. That is why it is called the exponential function. X is in the role of exponent. F of x is equal to e power x, that is what is called a exponential function. Frankly speaking, natural exponential function. When the base is e, it is called natural exponential function, whereas when the base is 10, it is called a common exponential function. In particular, if we choose b equals 10, then we get fx is equal to 10 to the power x, which is called a common exponential function. If we consider the number 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on, then that will be a number denoted by e whose value will be less than 3 and greater than 2. Why it is greater than 2? That is very simple. Here you can see the first two terms itself is 2 and then third term is 0.5 and then plus again some positive terms are coming, so it is of course greater than, and approximate value of e will be 2.7. So we can choose this number as the base, then our exponential function, that is y is equal to b power x, becomes here e power x. Then we take f of x is equal to e power x. Then this exponential function is what is called a natural exponential function. Natural exponential function. Natural exponential function. Let b greater than 1 be a real number. Then we say logarithm of a to base b. Retake. Let b greater than 1 be a real number. Then we say logarithm of a to the base b is x if b power x is equal to a. Simply speaking, this is the exponential form and we can write the corresponding, that is logarithm of a to the base b is equal to x. So we are writing in another language, that is the language of logarithm. So we can write the logarithm. So simply speaking, when we write 8 squared is equal to 64, that is the exponential form. Equivalently, one can write logarithm of 64 to the base 8 is equal to 2. That's all. Or we can say another example. If 64 is equal to say 4 cube, if 64 is equal to 4 cube, then we can write log 64 to the base 4 is equal to 3. So it is very clear that when we change the base of the logarithm, though the number is same 64, that is same here and here 64 number is same, but we just change the base to 8 to 4, then answer is changing. So logarithm is actually the power. Logarithm is actually the power. So here 3 is the logarithm. Log 64 to the base 4 is 3. So that is the power here. So if we write say 10 square is equal to 100, then you can write logarithm of 100 to the base 10 is that power, that is 2 here. That's all. This is the meaning of a logarithm. Logarithmic function with the base b is defined from r positive to r, that is from the set of all positive real numbers to the set of all real numbers. Then it will be mapping, it will be associating x with a y value which equals log of x to the base b. And the meaning is that b power y should be x then. That is b power y is equal to x. Then you know logarithm of x to the base b is y. So this function is what is called a logarithmic function. The function f given by fx is equal to log x is called logarithmic function. Here when we write log x, the base e is there. If the base is 10, then the logarithm is called a common logarithm, and if the base is e, it is called a natural logarithm. That is y is equal to log x to the base b. This is what is called a logarithmic function. Logarithmic function, where base b is a positive real number greater than 1. Now, what about the derivative of e power x, that is derivative of a exponential function, and that is e power x only? Without a proof, we have to learn this in 12th class. Again, derivative of log x with respect to x, that is equal to 1 by x. Proof of these two theorems skipped from 12th course. However, for the second, that is derivative of log x, what is it? So you know that here base is not written means that is understood the base is e only. When base is e, we are not writing. So let y is equal to logarithm of x to the base e. So which implies, you know, e power y is equal to x. That is the meaning. E power y is equal to x. So we can differentiate both sides by with respect to x. That is d by dx of y e power y equal to d by dx of x. Then what happened? That is derivative. Here variable mismatching problem. Wherever the variable mismatching problem is there, that we have to address. I told you that is d by dy of e power y, then dy by dx equals. Now derivative x with respect to x, that is 1 only. So we have like this. So which implies, what is derivative of e power y with respect to y? That is e power y only into dy by dx, that is equal to 1. So from this we can write dy by dx equal to 1 by e power y. And you know what about e power y? E power y is nothing but x. So e power y is x only. So you can have 1 by x. So that is derivative of log x. Log x means I told you to the base e, that is understood, that is equal to 1 by x. Logarithm of a product, say pq, to the base b could be written as logarithm of p to the base b plus logarithm of q to the base b. So this formula is helpful sometimes in solving problems. Again we can have logarithm of p square then to the base b. You know that is logarithm of p into p to the base b. Then using the above, that is log p to the base b plus log p to the base b, that is 2 times log p to the base b. Or simply speaking, this power where it is 2 here, then that power coming in front, that you can see here, this power is coming here. So we can generalize, that is logarithm of p power n to the base b, then which could be written as n times logarithm of p to the base b. This very important rule, so we have to recollect it. That is logarithm of p power n to the base b equals n times logarithm of p to the base b. Another rule is logarithm of a quotient, that is log p by q to the base b, that is log p to the base b minus log q to the base b. So these are the rules you have to recollect for logarithmic operations. We know many methods to find the derivative of function till now. Suppose we are given the function, say y is equal to x power x, then the derivative dy by dx, how to find it? So here comes the relevance of a logarithmic differentiation. So first of all, we shall take a logarithm both sides, that is log y is equal to log x power x, that is nothing but x time log x, as I told you earlier. So we have log y is equal to x log x. Now we shall operate differential operator both sides, that is d by dx of. Then what will happen? On the left hand side there is a problem of variable mismatching, so we have to address it, that is d by dy, then log y, then to compensate dy, then we have to write x like this. Right hand side there is a product rule, that is x into derivative of log x plus log x into derivative x, that is 1 only. So if you write or not write, no problem. So which implies, now what about a log y? Derivative log y with respect to y is 1 by y into dy by dx equals x into d by dx of log x, that is 1 by x plus log x. Then x getting cancelled, so we have 1 plus log x. Then what about dy by dx? So dy by dx equals y into 1 plus log x, that is y. We can replace x power x, then into 1 plus log x. This way we can perform the logarithmic differentiation. One more question I will show you, that is say y is equal to sin x to the power x. Then first of all we have to take a logarithm both sides, that is log y. When we take a log left hand side, then that will be x times log sin x, this way. Then we have to operate, that is d by dx, the differential operator, on left hand side and on the right hand side as well. So what will happen? So that is like this. Now here we can change the variable accordingly so that we can find the derivative. Then here you can, without changing, or we can do it directly. How it is? Suppose you change this x to y, then derivative log y with respect to that, 1 by y, then to compensate dy by dx, then things will be much easier. Then here first into derivative of second, that is log sin x plus, then second into, that is log sin x into derivative x, that is 1. You need not write. So what happens? So that is 1 by y, let it be there, then dy by dx, that is equal to x into, how will you find the derivative of this? So that you have to do in a substitution method, that we can do. That is, suppose you substitute sin x is equal to say something b, then we have d by dx of log v only, but the variable mismatching problem is there, so we have to address it, that is d by dv log v, then to compensate dv by dx, that is you can have 1 by v. How it is? Derivative of log v is 1 by v into dv. What is v? v means sin x. So derivative sin x with respect to x, that is cos x. That is cos x by v. What is that? Cos x. Cos x by v. v means sin x. That is you have cot x. That is you have cot x. So you can substitute it directly here, that is cot x plus then log sin x as it is, log sin x as it is. So what will be the answer? So the answer will be dy by dx equals y into x cot x plus log sin x. That is y. What is y? Y means sin x raised to x. Then x cot x plus log sin x. Like this. So that will be the answer. Now find the derivative of the function given by y is equal to say a power x, where a is a positive constant. Then we can find first of all logarithm, that is log y is equal to, when we take log on the right hand side, what will happen? That will be x log a, where log a will be a constant. Now how to find the derivative? Since it is y, we have to write first of all with respect to y. First of all, we have to write log y with respect to y, that is 1 by y. Then dy by dx, that is equal to, then first here log a is a constant, so log a you can take it outside, that is log a. Then derivative x is 1, so you need not write it. So our answer will be dy by dx equals log a into y. So what is log a? That is a power x then log a. So that will be the answer, a power x log a. If we are given y equals say x raised to sin x plus sin x raised to cos x, then how to find dy by dx? So don't take log directly, because there is no formula for log a plus b equals, we can't write it as log a plus log b or something, so we can't do anything there. Here it is a plus only. So what we have to do is, we will take this as a sum of two functions, so that is equal to y is equal to u plus v, where your u will be x raised to sin x and v will be sin x raised to cos x, like this. Now what happened? When y is equal to u plus v, you want u dy by dx, so that is equal to du by dx plus dv by dx. Now the things are quite easy, because you can find du by dx. Why? Because you have u is equal to x power sin x. X power sin x. Then you can take a log, that is log u is equal to sin x, then log x, like this. Then you can find du by dx from this. In the same way, since v is equal to sin x raised to cos x, you can find dv by dx also here. Then separately finding du by dx and dv by dx, you come to this equation star, then you combine the answers so that you can have dy by dx. We can have another example. If x equal to a cos theta and y is equal to a sin theta, then what about dy by dx? So since x is a function of theta, you can find dx by d theta here. That is derivative of a cos theta with respect to theta. So that is equal to a into derivative of cos theta with respect to theta is minus sin theta. So you can have like this. So you can write minus a sin theta. And then what about derivative of y with respect to theta? That is dy by d theta is equal to derivative of a sin theta with respect to theta. That is equal to, again a being constant, you can take it outside, and derivative of sin theta, that is cos theta. Now you have both sin theta, both dx by d theta and dy by d theta. Then requirement is dy by dx. that is equal to dy by dx. So you can have here by d theta by d theta. That is, we are finding the derivative separately and then dividing. So you have dy by d theta is a cos theta. That already you have. That is dy by d theta. Then what about dx by d theta? So that is minus a sin theta. Simplifying, you can have negative cot theta. So this is simple. Now we are going to solve a very interesting problem. That is, if x equal to square root a power sin inverse t and y is equal to square root a power cos inverse t, then prove that dy by dx equal to negative y by x. Here we can proceed in two ways. The first is our conventional method, usual method. Since x is a function of t, you can go for dx by dt. For that a chain rule, etc. we may apply, somehow you can find it. And then again dy by dt, that is dy by dt you can find, because y being a function of t. Then after getting dy by dt and dx by dt, you can go for dy by dx, which equals dy by dt divided by dx by dt, and further simplifying you can reach that is minus y by x. This is the first method, you have to complete it. But here in the second method, that is a very interesting second method, a little. So since x equal to square root a raised to sin inverse t and y is equal to square root a power cos inverse t, why don't we multiply xy first of all? Instead of differentiating, first of all we are multiplying xy. Then we are simplifying this. Then finally we will differentiate. That is xy equals that is square root a sin inverse t into a raised to cos inverse t. So you know by exponential rule, that is a raised to sin inverse t plus cos inverse t. And you know that there is a very interesting result in inverse trigonometry function, that is this equals pi by 2. So what happens, you know, that is we have xy is equal to square root a raised to pi by 2. That is a constant, say k. K is a constant. Then if we go for derivative of xy, that is derivative of a constant k, that will be 0. Now what about the left hand side? That is first into product rule we have to apply. First into derivative of y with respect to x, that is dy by dx plus second into derivative of first x, that is 1 only, so we need not write it, and then that is equal to 0. So from which we can easily find dy by dx is equal to negative y by x. The same answer that we can obtain in the previous case. So this method will be much interesting.